Before the video starts, I want to state that I do not condone piracy. I do not condone piracy with BitTorrent, with IPFS, with Hypercore, through Tor. In general, I do not condone piracy in general. Thank you, and yeah, thank you for watching the video. Hey, hello, thanks for watching this video. So, I want to talk about a couple of cool software that I have discovered. I'll give you a brief explanation first. The first one is Agregore browser. It was created by Ranger Mauve. They are a developer, of course, uh, and they are the creator of Agregore browser. That is them right there. So you can just go to their GitHub profile. So, but yeah, so we're on the Agregore repo. So what it is a yeah, it's a peer-to-peer browser. And how it would work is, for example, currently we are on github.com on the Agregore profile and then Agregore browser repo. Now, the important part is right here, HTTPS. That is the protocol we're using. We're using the HTTP protocol. So that is a client server centralized server protocol. It has a centralized server that you speak to. So what this does is the Agregore makes it so where you exchange data through the peer-to-peer networks. So there is no server in the middle. Now, it could still use HTTP. That's a given. But yeah, so the added features are the peer-to-peer network. So you can still use HTTP, but you'll be able to use BitTorrent, IPFS, Hypercore. There are other, protocols that it offers, but those are the ones that come to mind. So yeah, so this link that you're seeing, github.com, HTTPS, what that would look like in the practical sense in the real world, what would happen is that you'll get links. You'll upload data and download data, and it's going to be directly with other people. There is no middleman. There is no Twitter or Facebook in the middle. It's just you and other people exchanging and sharing data amongst each other, between each other. Again, just direct data sharing. So in the practical world, what that would look like is that instead of an HTTPS, this would be BT, standing for BitTorrent. It would be a BitTorrent link, BT slash colon colon, some link. And I'll show you those links in a little while. For IPFS, IPFS protocol will be IPFS slash colon colon, pretty easy. And for Hypercore, Hyperswarm, ecosystem, whatever you want to call that, is Hyper. There you go, Hyper. Now, this part though, it's not going to be easy to remember. Because it's going to be like a very long key or a hash or something like that, and it's going to be hard to remember. But we'll talk about that later. So that's what it is. Now, the one that I'm more familiar with is hybrid browser. So hybrid browser was created, or not created, but it's basically a fork of Agregore browser. It was copied. So the developer that works on hybrid browser is Ducks and Goats, and they forked Agregore browser and made their own changes on top of it, and yeah, and that became hybrid browser. So I think the repo is hybrid where, if I'm not mistaken. Yes, it is. There you go, hybrid browser. So yeah, so Ducks and Goats created hybrid browser, forked Agregore, made their own changes on top of it. I'm more familiar with the hybrid browser, and that's what I'm currently using. So yeah, so Now I'll give you practical examples of what that would look like. If I'm going slow, I'm not used to making videos, so whatever, just put up with it. Okay, so there you go. So here is the BitTorrent portal. This is what you will use. This I'm sure will be updated later on. Oh, if you want an about link, there is an about. Hybrid slash colon colon about. This is basically the about section of the web browser. Just a basic page that just talks about it. Their handles and all that, and protocols it supports. So yeah, so let's go to BT. Now BT again stands for BitTorrent. So let's say that um, let's say I want to upload some data. Let's give you an example. So is this a directory? I am uploading the files right now, the website files right now. Why it's not showing you anything is because on OBS I was following the window. I was capturing the web browser window, not my full monitor, so it's not showing you any of the files or that uploading files dialog box that comes up, whatever you call that thing. So that's why you're not seeing any of the files. But basically, I'm uploading um, the website files right now, the example files. Um, no, no, we're just gonna upload files. I'm gonna upload this. Let's say I'm gonna upload this website. Okay, right here. That's the full website. Open. Okay, it was not a directory. It was files. So since it's not a directory, I'm gonna do files. And what immutable means is that with BitTorrent, BitTorrent is a protocol that can be updated and upgraded as people work on it. So there are two ways uh, to work with BitTorrent. You can make immutable data, which is the default way BitTorrent works. With BitTorrent, you upload data, and BitTorrent takes that data, compresses all the lines in their lines of code and just everything, and they compress it down to a hash, a hash identifier, and that is the info hash. You don't really have to worry about it. You can even just ignore what I just said there. But the main thing to understand is that uh, if someone has the same exact file, so let's say I have a notepad file, a txt, text file, and inside that file I just write test, and another person has the same file. They copied and pasted on their computer, and it's the same file. It's a text file. Inside that text file, someone just writes out test. Test. One person has test. Another person has test. Now, uh, so two people have the same exact file with the same exact content. What happens is that BitTorrent will create, since they're the same, really the same file, BitTorrent will create a hash, an identifier unique to that. Now the thing is, since they're the same file, that identifier points to both of them. Okay, it's a stand-in, it's a name for both of them. That is the info hash. All in all, the info hash is an identifier. It's like a URL. You paste the info hash in, and the BitTorrent network will know what you're talking about. Oh, okay, you're looking for that piece of data, that file. Okay, so enough of that. I already selected the files that I want to upload, and I want to create an immutable torrent. So a regular default torrent. All right, so let's go ahead and submit that. He's got to wait. There you go. So it's uploaded. So here you go. This is all of the important information that we're needing. So this is the info hash. This is the identifier. Instead of, see, this would be http colon slash slash github.com. Instead of that, oh, what's happening? Okay, well, it's taking some time. Let me see if Okay, well, this is pre-alpha software. Okay, so this stuff happens. All right. Okay, so let's just keep on going though. So with http colon slash slash github.com, instead of seeing that, you're seeing a bt colon slash slash that right there. That's the identifier. That's the info hash. That definitely is not github.com. That's not facebook.com. That has no like it's just you can't remember this, and that's what I was talking about. See, the info hash, the unique identifier, is part of the URL. So no http slash colon colon uh I easy name I can remember.com. It's bt for bittorrent slash colon colon, then the info hash. That is the URL. That is the identifier, and that's the full link. Slash html dot or slash index dot html. Let's go there and see what that looks like. So essentially, what we're doing, we are creating torrents on this web browser. The torrents are the websites basically. So this info hash, and I'm going to talk about this more in depth later, but this info hash is something that you can paste on your BitTorrent client that you use. For example, let's say you use QBitTorrent. That's a popular one. So let's say you use QBitTorrent. You can go in there, add a torrent, and just paste this URL or this info hash right here. Just paste this, and then what will happen is that you'll be downloading this website that I just, or this torrent file that I just uploaded from this web browser. Um, Again, though, let's just keep on going. See what that would look like. There you go. So that is the info hash. And again, same thing, info hash. And these are the files. These are the actual content of this torrent. These are the individual files of this content. Uh, so yeah, index.html. Let's click on it. There you go. Tristero is a matchmaking JavaScript library, basically to match. It's using WebRTC, so um, and it uses BitTorrent, IPFS, Firebase, but basically what it does is uses WebRTC to connect different people together in like a room, quote unquote room, and then you can exchange data and things like that. So that's basically it. I just took their source code from from GitHub. I just took the source code from GitHub and upload that. So yeah, and that's another person. So it looks like they're on the same. They're using the demo as well. Yeah, it's a pretty fun thing. Either case, yeah, so this is what it would look like. Now, remember, if you go over here, it is not HTTP slash colon colon something. It is a BT colon HTTP colon slash. My God, I'm forgetting my words. I didn't sleep much today, so whatever. So yeah, so it's not HTTP colon slash slash. It is BT colon slash slash. Again, what it means, it is BitTorrent. We're in the using the BitTorrent network, and this is the info hash. And there you go, index dot slash index dot HTML. So we are using the BitTorrent network through this web browser. We are using the BitTorrent network in a way where it's basically we're using regular how people know the internet as. We're using the BitTorrent network as how the internet is as we know it. How the internet is as we know it. That's basically it. When people go on their web browser, what the internet, quote unquote, the internet is, as they know it, is basically Chrome, and you press or you click on the URL bar and you type in google.com and it goes somewhere, and that we're doing the same thing, except we're using a totally different infrastructure, different. I mean, just everything. We're using BitTorrent. So yeah, so that's one example. Now this link, Now, the next step is what happens with this. Okay, this is great. Okay, cool. That's fun. Nice demo. But what really is the big thing here? What it is that this link is just like any other link. This is shareable. You just copy this and you just send it to someone, or you message someone, whatever. You just paste it anywhere, and they can take this same link, and if they have this web browser, agregore or hybrid, uh, what they can do is they can paste this link just like here, press enter, and they're seeing the same thing, except again, no HTTP. It's using BitTorrent. So, it's pretty cool. Let's do that one more time. And now let's go. Let's go back to the homepage. Now hybrid uh, also has support for Tor. Now you need to have Tor on, and so you need to have Tor on. And let me turn it on. Oh, all right. So I'm turning Tor on right now. So you need to have Tor turned on and running, and it runs on port. Default wise, it runs on port 9050. So you need to have it running, and once it's running on the background, and I do have it running now, uh, what you'll be able to do with the hybrid browser is so use Tor. So I'll give an example. So the protocol handler, the protocol part, where it says hybrid or HTTP, it is Tor, or if it's secure like HTTPS, because what it's doing is basically is doing a regular HTTP request, but it's running it through Tor. So if you're doing HTTP, then you're doing Tor, Tor. If you're using if it's secure, uh, and you have a certificate, SSL certificate, or TLS, then what you're doing is HTTPS. But then what happens? It becomes TORS, TORs. The S again is for the security part, secure part. So what that will look like is, let's do google.com. So TORS. So TORS is a stand-in for HTTPS. Okay, press enter. There you go. Now I'm not. You can see that it's using Tor. It's changing this, and it's like that. Like you can tell that I'm using Tor because I am in. That seems to be another font or another language there in the middle. Um, so let's do twitter.com. Again, this is going through the Tor network. Um, oh, there you go. So Twitter can, it's predicting, it can detect that I am, going somewhere else. I'm connecting from a different country or something, different IP address, different language thing. All right, so oh yeah, there's also another way of showing that. Yeah, there you go. IP API dot IP file, whatever. Just click on that. This will return what IP address we're connecting from, or that it detects. Give it a little while. There you go. That is not my IP address. Okay, so that's Tor. Um, Now the thing is though, the web page that you're viewing, you might be connecting that one request, this just initial one request. When we press enter, you are making one request. That initial request will be routed through Tor, but remember, in an HTML page, you might have 12 requests in this. Give me 1 second here. All right, welcome back. Looks like they're uh, looks like the software, the web browser, it crashed. So remember, again, it is pre-alpha software, so it can crash, but we're back. So we ended at using the Tor feature, so the Tor handler. One thing I should probably explain is the handler part. See, these are protocol handlers. These have protocol handlers where if you type in hybrid or IPFS or Tor, uh, this software has a handler for those protocols and it routes through this request from that handler. So this Tor thing is a protocol handler. So what I was explaining is that when you're using this protocol or a Tor handler, when you're using the Tor protocol on the hybrid web browser, it routes that one request. So, for example, Tor S for secure :// If I press enter, it is routing just this one get request from it is routing just this one get request uh, through the Tor network. But this web page that I just went to has a whole bunch of other requests. That request right there, if you go and inspect these links, for example, right here, that is an HTTP request. It doesn't have TOR. Uh, okay, it does because that's a relative link, but basically what I'm saying is that if there is a let's say someone has a website that you went through, that you went to using this protocol, this TORS/:, something.com, like a small website. If they have hard coded links, not relative links like this, but hard coded links that they start with HTTP, that basically means is that it's not going to be using this Tor protocol handler. I'm getting into the weeds, I'm getting deep, but it's just something to remember, because if you make a website just for this web browser, you have to either use relative links, or you can just use hard code TOR or TORS in there, and then that will use this protocol handler. So, all right, so that's Tor. Now let's go into IPFS. So IPFS. All right, so let's upload an image. There you go. It's already uploaded. So this is the link. So you see it right there. Starts with IPFS. This part is really remember. People are not going to remember this. So that's why. The helpful thing is to have a database that automatically saves this or something and goes from there, because people are just not going to be able to remember this. All right, so go into it. There you go. There you go. This, you uploaded this. The data stays in your computer. It created a link. You put the link in there, and now it's retrieving all these files from your computer. This is all done in this computer, and when it is shared, this is shared in peer-to-peer fashion directly with other people. So again, if you copy this, okay, you copy it and you message it to someone else has it, they put it on their computer using this hybrid web browser, they put it on their computer, they paste the link, they are pulling it directly from you, from your computer, or from someone else in the network that has a copy of this file. Maybe someone else pinned it and has it on their computer as well. So that's IPFS. And one quick thing again, remember, protocol handler. It's using the IPFS network. Let's do this with Hyper. So this is the Hypercore, Hyperdrive, Hyperswarm ecosystem. I guess I don't know, but I'll just call it Hypercore just to make it easier. This is the Hypercore ecosystem or Hypercore network. Um, so yeah, so I'm gonna upload the same image, and there you go. This is the link. I should probably talk about why one network seems so different than the other when it comes to their identifier, and I'll talk about that. So bam, there you go. Same thing. We did the same exact thing that we did with IPFS, except this time we're doing it with Hypercore. So now let's check IPFS. Okay, so let's talk about why it looks so different. So why it looks the identifier here, that looks different from what we just saw with Hyper. So with IPFS, the unique identifier is like it's a hash. You feed it data. So for example, I fed the IPFS network this piece of data, this image. It took all that code in that image, and compressed it down to this hash. This hash is basically the addition. It's the total it's the code in this image, and it runs a mathematical function, this hash function, and it creates this unique identifier. If someone else has the same image, this exact same image, and they upload it to the IPFS network, or at least using this web browser, they would get the same exact identifier. So it's content hashed, basically meaning the the main attraction here, it's not the user, it's the content. So if someone puts an identifier in the network, they it's going to find the nearest person, nearest user who has that same identifier, same content. Okay, so when you upload something on the IPFS network, you get this hash and a unique identifier. You paste it, or you put it in, and what you get is the nearest person who has that piece of content, that media file, whatever you're looking for. So yeah. So again, same thing. You shared this. Someone message it to someone. They paste it. They get this. All right. So now let's do that Hyper again. So now, how come the same image? How come with Hyper? Why is their keys or their identifiers so different from IPFS? That is because Hypercore uses public keys. They do not use a content hash, meaning that it's not taking it's like IPFS, what I said before, it takes all of the code in this image, compresses it, creates a hash, and gives it to you. IPFS uses this image. This image has a play on that name, that identifier. With Hypercore, it does not use the image's code. It does not, the image itself does not have a play on its own name, on its identifier. What happens is that Hypercore creates a public key. It's a key, and the key is what identifies that piece of media or that data structure. I think that's how it works. Again, these are all like a whole bunch of background stuff. Of course, if you guys want to research about Hypercore, IPFS, and BitTorrent, of course, do that. But that's from my understanding. But the big thing is that we're utilizing Hypercore here. This is a public key, uh, or I think this is the identifier for the key. But whatever, doesn't matter. For our use case, this is how it works. So yeah, so that is how Hypercore works. Again, same thing, copy it, paste it somewhere, give it to someone, they paste it on this web browser on their computer, same thing, they grab it directly from you or someone else who has a copy of the same exact thing. So how that works. Now, one thing I forgot to mention is that BitTorrent. I said that BitTorrent immutable data. That's the default way of. That's how BitTorrent works. It takes a package of files or maybe one file, um, and it makes an info hash. It makes a hash, runs all of that code inside those files, makes a hash out of it, and that hash is the info hash. That hash is the identifier. Now, BitTorrent is an updatable protocol. People can make updates to it. There is one update called BEP 46, BEP 46. What that does, it introduces public keys. So what happens is now you can make updatable torrents. Usually, basically torrents, how it works is that it is immutable, meaning you cannot change it, you cannot mutate it. So a torrent stays the same. If you change a torrent, you're changing its info hash, you're changing its identifier. It's a new torrent basically. So with torrents, with BEP 46, they introduce public keys, meaning now a key can be a name for info hash. What you do is the public key is the name, is the identifier for it, and whenever you have a new update, you attach it to a new info hash, so it's pointing at the newest info hash, and that's what we're going to do. So we're going to upload the same exact site, and hopefully it doesn't crash again. All right, there you go. So we're gonna upload the same exact site that we did before with BitTorrent. Okay, and very soon we should get a public key, and we're gonna get a secret key. Secret key is gonna be very important, and we'll talk about why right when we see it. All right, there you go. So this is the um, half of the important piece of information data that we have. So this is way bigger than an info hash. That is because that is a public key. That is a public key, and that public key is the identifier for this torrent. It's really the info hash, but the public key is uh, it's basically a stand-in for the info hash. Someone pastes this public address. The public address points to the latest, most recent info hash, and poof, you get the torrent. But either case, for our purposes, this public key is, the name. That's the identifier. Now this right here is the secret key. If you lose this, you cannot ever make updates to this public key. So, for example, if you do something important and you want to make it's a very important piece of data and you want to make an update on that data, if you lose the secret key, you cannot make updates anymore. That's kind of like losing your losing your password for like your control panel for your corporate website or your company's website. You lost your password. uh you lost like the phone number for the phone number authentication where they can't send you code. You just lost all access to uh, accessibility basically to your company's website, and now you're screwed. You can't get in anymore. You can't make any more updates, nothing like that. That's basically the same thing. If you lose the secret key, you cannot ever make updates to this. So this is very important. You need to save this. You need to just have it somewhere. If you lose this, you're screwed. If you want to make updates to that public address, so you want to keep both. You want to keep the public key and the secret key. Both is very important. You want to save them. You want to keep them, or print it out, have it somewhere, whatever. Uh, okay, so yeah, so let's go ahead and see what that would look like. Right, so there you go. And this is the info hash. Remember, this is not the public, this thing is not the public address. This is the info hash. This is the public key, is the public address. Um, this is where you go to other torrent clients like BitTorrent. You paste this in, and then you can download this exact same torrent on those other clients. BitTorrent, I don't think I am. Basically, I'm really 100% sure BitTorrent and basically really all other clients, if not most other clients, if not all other clients, do not support BEP 46, meaning that you're not going to be able to paste this public address. This public address is not going to do anything. They're not going to know what that is. They're going to, this is what you put the info hash. So, yeah. And then, same thing, click on it, and we're, using BitTorrent and the identifier and the page, essentially a website and the link. All right, so that's the big three network. Hybrid also uses Gemini and Gopher. Gopher is you could do Gopher, but only getting resources, not posting or not uh, making new data, not posting new data. It also does Gemini. Agregore. So Agregore does all of this as well, except Tor. So, what Hybrid has available. Hybrid has Tor, but other than Tor, all the protocol handlers, all the protocols is really the same. For Agregore, no, actually, okay, take that back. Agregore has more protocols than Hybrid. The main difference is Hybrid only has Tor. That's the one extra thing it has, but Agregore offers IPNS, IPLD, PubSub. Those are high IPFS ecosystem protocols, ecosystem, layers, I guess, for lack of a better term. I don't really know how to explain it, but either ways, IPNS, IPLD, and PubSub. Those are IPFS products, projects. Of course, learn about them. PubSub, I think it's like a push method where it just pushes updates to everything else or everyone who's listening in for that update. Just a lot. Just research that. Just Google it or DuckDuckGo it, whatever. So yeah. So that is hybrid web browser. I'm just more familiar with it. I've been using it more than Agregore just because I just found that Tor functionality pretty cool. Yeah, and now basically why use it, why even be interested. As you can see, it had problems. It was doing the little circle problem, not responding. Yeah, it does have problem. It's these are things where like one person or like few people are contributing code. Agregore is led by one person. They're not millionaires, and Hybrid is also just contributed by one person, and they're not a millionaire either. So it's going to have problems. Obviously, this is not like hundreds of millions of people are not going to use this. I'd be surprised even if 100 people use it. So as like an everyday thing. But why even be interested in it? The reason why is because it's pretty cool. Just all the cool stuff is underneath, though. It's not apparent that you're doing the way you're using the computer and the way you're exchanging data is totally different. But no one really sees it. They just see a link. It's a link, sure, but what's that's step one. But after the link, step two and on, after the link, what happens underneath, that is the cool thing, where you get turned off on these networks, these platforms, these websites, for whatever the case. Let's say it's totally innocent, or it's not as bad. Uh, XYZ reason, get kicked off. Internet was talked about like, oh, it's data freedom, it's the highway, the information highway, and all that. And what is it now? It's basically Twitter, Facebook, Amazon, Google, Microsoft. Just name a handful of companies, and that's it. That's the internet. It's really where people are at. It's just really it's not dynamic. They say dynamic data. Ooh, it's Web 2.0. You can comment boards, and discuss and all this stuff. It's a dynamic data. It's changing. Mongo, MySQL, all this stuff, and it's just used for Instagram and Facebook and Twitter. It's again, is the word? Do you really want to use the word dynamic? It's not really dynamic. It's a very static thing. Maybe it's consolidated, and that's the way it's supposed to be. But um, at the same time, it's just not. It's just not fun. It's just not fun anymore. Uh, I don't really see a lot of content that makes me laugh or chuckle or smile. Like, it's just not fun. All that got sucked out. Um, Mid 2000s, you would just see a whole bunch of websites were more of a fun. It was more of a recreation, like like someone draws just because they want to, because they feel like it. It's kind of like that. Someone just makes experiments with HTML and makes a site. Let's say you go to their small site. Everyone had their own quirky take on sites and things like that, designs. It was just fun time for me. But anyways, um, these days the internet sucks, and this is one cool way of doing things differently, and has a very big practical um, standpoint too, which is privacy, and not only um, privacy as far as that. Maybe not privacy. I want to make it clear. In BitTorrent, you can't. Your IP is shown. Like that's a big part of it. You have to have your IP and share it with others because you're downloading and uploading things. But privacy, as in like you can share data with others directly, as in you don't have to be fearful that someone will come in the middle and turn you off. I guess what I'm saying is your access is private. No one can. I don't know the right words to say it, but not your rights. I don't know if this is a right or not, but your access is private. It's not like a trivial thing where someone can just cut it off. Like, hey, you can't share data anymore. You can't upload anymore. Get out of here. It's nothing like that. Uh, that access is there. It's respected. You upload data to the network and you download data to the network directly with others. So if you don't like a user, um, maybe you're using a website that in a network, a swarm of a torrent, and I can see that you're using their website. Someone else can take and upload the same website. Someone else can upload add a line or two and just upload the same torrent. Either ways, these are all cutting edge experimental things. But what I'm saying is that no one can turn you off fully. You know, uh, no one can conclusively cut you off. They could cut you off as far as like I don't know, like blacklist an IP. Okay, but that's that one swarm. You can join another swarm. You can create your own swarm. You could. What I'm saying is that you could upload data freely. Um, you go to Twitter, you post something, and they block you. Well, you're blocked. You can't go back to Twitter, or maybe you can't. Your account is gone. You could view only mode. I don't know. I'm not on Twitter. Best, like really, I'm not on Twitter at all. I go in there, view some stuff, but again, I'm not on Twitter. Um, but over here, there is no like a full turn off, cut off for you. If you're blacklisted or something, you just upload another torrent. You can always create. What I'm trying to say is that on Twitter, Facebook, these other places, regular internet as people know it, you can be turned off. Like in general, you cannot post anymore. You can view things, but you cannot post anymore. Through these peer-to-peer networks, you can always post. You you might be moderated off, you might be blacklisted, but you can definitely post still your own stuff somewhere else. If it gets more popular, people come over. That is where it can lead to, these links and everything coming together. These are a lot of separate things coming together in one piece of software. Again, it is pre-alpha. There's, I'm sure, a lot of problems with it. It's not ready for usage for millions. Again, I don't even think 1,000 people. But if it does, hey, great. That means we could make updates to it, and I'm sure the developers will make updates to it and take it from there. But yeah, as of right now, it's a very good experimental demo, and yeah, that's what it was. And it's also a learning progress for me. I don't know like everything about these different pieces of the different moving parts, the different pieces of technology here, but I know enough where I know what's happening. Maybe not 100%, but I know what's happening. How these networks work, and yeah, it's these are good projects. So that is what I want to talk about. Thank you for watching the video again, and have a good day.